Hi, engineers. This is Professor Dan at the University of Colorado Boulder. And I had a couple students come to me in office hours say, "Hey, I understand trig, but I'm a little confused about what you're doing in statics and how to do this." And so what I thought I'd do is I put together a little trig video and show just how it's a little different when we use it in statics. And the key is we got to practice so that this stuff becomes second nature. So I don't know if it's officially trig, but it's basically a bunch of triangles. What we said the first day is that drawing acute right triangles is going to be in our we got to get good at that. We got to be able to see things. And so we know c squared equals a squared plus b squared, and we know SOHCAHTOA. And so the sine of theta is equal to opposite a over c. Cosine of theta is equal to adjacent over c, and the tangent of theta is equal to a over b. So that's trig. But one of the things we see in statics is that we care about forces. We'll get to some other stuff, but for the most part, we have just some force. And a force is a vector, so it's got an arrow, it's got a direction and a magnitude, and let's call the magnitude F. And so now I said you gotta draw your own triangles. So in our problems, we gotta draw our own triangles. And so just draw a triangle. You can draw whatever kind of triangle you want, but for me, horizontal is the x-axis and vertical is the y-axis. And we know when we sum vectors, we go tip to tail. And so f of y we draw as a triangle, but it actually acts at this point right here. So just kind of keep that in mind. But yeah, so how do we go about using this? And one of the things that we see is we say f is the square root of f of y squared plus f of x squared. So f is the hypotenuse, so its magnitude is our y component squared plus our x component squared and the square root of that. And then we have this theta, and we say sine of theta is equal to opposite f of y over f. And we say the cosine of theta is equal to f of x over f. But we often don't do that. What we often care about is solving for f of y and f of x. So what we often see is we move the f over, and we just say f of y is f times the sine of theta, and f of x is f times the cosine of theta. And if we look at this, in my mind, when we have theta as an angle in relation to horizontal, the x term is the adjacent term, and so it's f's adjacent to our angle, which is our cosine, and our opposite, our y, is often our sine. Now I say often because every so often, especially if we have an f that's drawn in that direction, we have our theta drawn not in relation to the x-axis, but the y-axis. So in this case, f of y and f of f, we see that SOHCAHTOA says f of x over f is the opposite, and opposite is our sine. So sine of theta, should have probably said that opposite. So sine of theta is equal to f of x in that case over f. And so it all depends on how you draw your triangles. So making sure you understand SOHCAHTOA, making sure that for the triangle that you draw, you're staying consistent. That's the key. And what we'll see in statics is our answers that we come up with numerically have to match our drawings. So just be careful and practice, practice, practice. So I think that's about it. I will see you in the next video. Have a great day.